Good morning. I am Gayatri, PGT Chemistry from JNV Kadapa. Today I am going to explain what are coordination compounds. Before we learn what are coordination compounds, let us first learn about salts and their classification. Salts are broadly classified into two types: simple salts and molecular or addition compounds. What is a simple salt? In your lower classes, you might have learnt about what is neutralization reaction. A reaction in which an acid reacts with a base forming salt and water is called as a neutralization reaction. Here you can see the reaction between potassium hydroxide and hydrochloric acid. They react forming KCl and water. What happens when a salt is dissolved in water? It ionizes, producing its constituent ions. And when you test these ions, they give a positive test. That means when you are dissolving potassium chloride in water, it dissociates, giving K plus ions and Cl minus ions. And when you test for the presence of K plus and Cl minus ions, they give their confirmatory tests. Now let us see what are molecular or addition compounds. They are classified into double salts or lattice compounds and coordination or complex compounds. Double salts or lattice compounds. These are molecular compounds which are formed by the evaporation of a solution containing two or more salts in stoichiometric proportions. The molecular compounds which dissociate in solution into its constituent ions are known as double salts. Double salts retain their properties in solid state. For example, potash alum and more salt are double salts. Potash alum is K2SO4, Al2SO4 taken thrice, 24H2O. More salt formula is FeSO4, NH4 twice SO4, 6H2O. When potash alum is dissolved in water, it produces K plus ions, Al3 plus ions and sulfate ions. And when you perform tests for K plus ion, Al3 plus ion, sulfate ions, they give their confirmatory tests. Now let us see what are coordination complexes. A coordination compound is formed from a Lewis acid and a Lewis base. The molecular compounds do not dissociate into its constituent ions in solution. Such compounds are called as coordination compounds. One such example is potassium hexacyanoferrate complex. Here you can see potassium hexacyanoferrate complex, when dissolved in water, produces two types of ions, K plus ions and hexacyanoferrate ions. In potassium hexacyanoferrate, the individual components lose their identity. The metal of the complex ion is not free in solution, unlike the metal in the double salt in solution. Now let us sum up the differences between double salts and coordination complexes. In double salts, they completely ionize in aqueous solutions, and each ion in the solution gives corresponding confirmatory test. That means when you are dissolving potash alum in water, it dissociates, producing three types of ions, K plus, SO4 2 minus and Al3 plus ions. And when you perform test to check the presence of these ions, they all respond to the test and give their confirmatory tests. Now let us see what happens in a coordination complex. A coordination complex dissociates incompletely in its aqueous solution. This gives a complex ion which does not completely ionize. For example, potassium hexacyanoferrate complex, when dissolved in water, produces K plus ion and hexacyanoferrate ion. Here, hexacyanoferrate ion does not ionize completely. And that is why when you test for the presence of Fe2 plus ions and Cn minus ions, these ions do not respond to the test. Now let us see what are coordination compounds. The compounds in which metal atoms are bound to a number of anions or neutral molecules are called as coordination complexes or coordination compounds. Now let us see what are the important applications of coordination compounds and why we should be learning about coordination compounds. Due to the formation of cyanide complexes, we are able to extract gold and silver from their ores. And you know the importance of hemoglobin and chlorophyll. These are biological pigments. Chlorophyll is present in plants and is responsible for photosynthesis. And hemoglobin is the pigment present in red blood cells and is involved in transport of oxygen and carbon dioxide in the body. Ziegler-Natta catalyst is a complex. It is used as a catalyst in converting ethene into polythene. So you can see here the complex. Ziegler-Natta catalyst complex can be seen here. It is a combination of triethyl aluminium and titanium tetrachloride. And a complex metal catalyst is also used in hydrogenation of alkenes. And how do you test the presence of Cu2 plus ions in a given salt? In class 11th, you might have performed a test for Cu2 plus ions. You prepare a salt solution and add ammonia solution. Then you get a blue precipitate which dissolves in excess ammonia, producing a deep blue colored solution. Here also complex forming ability is used in the detection of Cu2 plus ions. So these are some of the applications of coordination compounds. We will be learning about many more applications in our present chapter later on. Okay? Thank you very much for listening to me carefully.